In lesson 1, we talked about ratios. Today we're going to talk about a specific kind called unit rates. So a rate, just in general, this first sentence isn't about a unit rate, just about rates in general. A rate is a ratio that compares two quantities with different measures. Usually, not always, I shouldn't say usually, often time will be a factor here, but not always, or money. So a rate is a ratio that compares two quantities with different measures. A unit rate is when the ratio has a second term of 1. That's why it's called a unit rate, because uni means 1. Uniform is called that because everybody has one form of clothing they wear when they're on a team. It's all the same style of clothing. It's called a unicycle because there's one wheel. It's called a unicorn because there's one horn. So it turns out this is pretty straightforward. To calculate a unit rate, divide the numerator, the top of the fraction, by the denominator. Yep, surprising. You do the top number divided by the bottom number. As you're doing that, you'll always just take the first number and divide by the second number. So like this one, for example, I'll go ahead and do. We'll come back to this in a second. 64 cans and 8 boxes. So this is a rate. This is the ratio, 64 cans and 8 boxes. But to figure out the unit rate, we need to divide 64 by 8. So 64 divided by 8 is 8. That means while there are 64 cans and 8 boxes, there are 8 cans per box. So we're finding out if there's this many in 8 boxes, how many are there in just one box? That's what the unit rate. So like I said, you always just do the first number divided by the second number, but there is an exception. When dealing with cost, the money will always be the numerator. So you'll always put the money first when you're dividing, even if it's not what they list first. So while saying money is always on top is not a good life lesson or life model, it is true as far as this math is concerned. If you see money, it always goes on top of the fraction. So always keep the money on top. Okay, so 264 points scored in 22 games. So this might be a basketball player. They played 22 games this season. They scored 264 points in total. So we can divide these and find out that they scored 12 points per game. Now here's why I gave that hint. They put the drinks first and the money second, but we do not do 5 divided by 630. When there's money, the money always goes on the top of the fraction. So we do 630 divided by 5. Let's see what that is. I know it's just over $1, but I can't remember beyond that. So 630 divided by 5. So that's $1.26. So that means it's $1.26 per drink. And I wrote it this way to make sure you know you can certainly write the word per, B-E-R, or if you want to do a slash like this, that's a common way to say the same thing. So it's $1.26 per drink. Okay, this is about typing speed. So someone was able to type 2,400 words in 30 minutes. So 2,400 divided by 30 is 80. So they're able to type 80 words per minute. Some boxes have been delivered to Goodwill, and they figured out that there's 36 books in total. So we can divide 36 by 6 to figure out that means there's an average of 6 books per box. As you may remember, actually let me pause here. I'm going to keep going, but but I'd encourage you, if you're watching, pause and see if you can do the last 3 on your own. When we do the big Super Bowl of caring to donate canned goods for the hungry, there's often those huge bins they put out by the office. So let's say there's 560 cans in 7 bins. We can figure out how many there are in each bin by dividing. So 560 divided by 7 gives us 80. So that's 80 cans per bin. Okay, and sorry, this is supposed to be 72. I have a typo there I gotta fix. So 72 ice cubes in 6 trays. So 72 cubes in total divided by 6 trays gives us 12 ice cubes per tray. Okay, our last one, we might be looking at cooking and see that someone made 7 batches of cookies and they used 15.5 cups of sugar. Well, we just want to make 1 batch, and so we're trying to figure out how many cups of sugar we should do. So you do 15.5 divided by 7. And you get a pretty long decimal. You can just round to 1 or 2 places. So it's about 2.2. So we should do 2.2 cups per batch. You can say cups of sugar per batch or just cups per batch. So that's how we find the unit rate. Notice every time we went from the bottom being a number that wasn't 1 to the bottom being 1, because that's 8 cans in 1 box, 12 points in 1 game, $1.26 for 1 drink, and so on. Now, there's some other ways we can use this, as you'll see here on the back. So an online rock music store sells 15 songs for $12. A country online music store sells 10 songs for $9. Which online store has the lower cost per song? So this also allows us to compare, because at first glance you might be like, oh, well, these have got to be the more expensive ones because that's $12. But they are offering more songs for that amount. So to figure out which one's actually cheaper per song, we can figure out the unit rate. Now remember, money always comes first. So we do $12 over 15. I believe we get 80 cents per song on that. That's the rock music store. For the country, we do $9 for 10 songs. That's 90 cents per song. So while this is more songs, or because this is more songs, the more money actually turns out to mean it's cheaper per song at the rock store. Okay, we can also use this to figure out how often or how much something will happen for a different amount of time. So let's say a typical dolphin will take about 34 breaths in 4 hours. How many breaths will a dolphin take in 7 hours? Well, we can do that by figuring out, using this information, 34 breaths in 4 hours. We can divide that . 34 divided by 4 gives us 8.5. So on average, they take 8.5 breaths per hour. So if we want to know how many breaths they'll take in 7 hours, we just multiply that 8.5 by 7. So 8.5 times 7 means that at this same rate, in 7 hours, they would take 59.5 breaths. So once we find the unit rate, we can then find out how much it would be for a different amount. We were told how many breaths they'd take in 4 hours, but we were able to use that information to figure out how many breaths they would take in 7 hours. So kind of like we did with the country music and the rock music, this is another way we can try to figure out who has the better rate. So if we're needing some golden ribbon, maybe for awards or maybe for a craft, we notice that Michaels sells golden ribbon for 15 cents per inch. Hobby Lobby sells golden ribbon for $1.95 per foot. So which store has the better unit price? So you might need like 3 feet. And you're thinking, okay, well, would it be cheaper for me to go to Michaels and just get 36 inches at this cost? Or would it be cheaper to go to Hobby Lobby and get 3 feet at this cost? So we can figure that out by doing the unit rate. Now on this one, what's interesting is we actually have 2 ways we could do it. We have 2 different measurements. We have inches and feet. So I'm going to show you both ways. We could say, all right, well, let's convert this to how much it is per foot and compare them. So if this is 15 cents per inch, I could multiply that by 12, and that's going to tell me how much Michaels is really selling per foot. So 0.15 times 12 gives me $1.80 per foot. So if we compare that to $1.95, it's smaller than $1.95. So that means Michaels is the cheaper cost. They have the better unit price. So we did it by changing the inches to feet. But you can do the same process by changing the feet to inches. So we'll get the same answer, but we could say, okay, let's look at Hobby Lobby's price. Hobby Lobby charged $1.95 for a foot. So I can divide that by 12 to see what Hobby Lobby is really charging per inch. So $1.95 divided by 12 is 0.1625. So they're charging 0.1625 per inch. And that's greater than just charging 15 cents per inch. So again, we see Hobby Lobby's price is higher. So Michaels has the better price per unit. Whether we look at the unit as an inch or a foot, foot's what we did first, inch was second. But either way, we see that Michaels has the better cost.